All right, kia ora everybody. Thanks for beaming in for my presentation. My name's Daniel Nutsford. I'm a senior geospatial analyst from Morphum Environmental. If you haven't heard of us before, we're a multidisciplinary consultancy and got a strong focus on environmental engineering, environmental science, and sustainability. And we've got a growing sort of geospatial team. So there's 6 of us at the moment, with a couple of new starters. And yeah, GIS underpins a lot of our projects, be it sort of in a small part for a small data project, or a sort of a big multi-year, big project where FME really sort of is the backbone to the analysis and sort of bringing all that data together. So yeah, FME is increasing at Morphum. We recently purchased a couple of new licenses. Like I said, got some new starters with FME skills. So it's quite an exciting time for us. So yeah, as per the title, this talk is going to be about urbanisation and the creep of impervious surfaces. And it's sort of focusing on a model that we've built with FME that lets us understand how impervious surfaces are distributed throughout planning zones. And the question we're really trying to answer is, are the limits as set by those planning zones suitable given the sort of climate change we're sort of already seeing happen and what's going to happen more in the future, and that population growth. So I can't answer all of those questions in this talk alone, sadly, but that's kind of the direction that we're heading with these projects. So a quick overview of my talk today. I'll give a quick intro and a background as to what some of the stuff we're talking about. And I want to introduce the concept of something called the maximum development scenario, which is how we can talk about impervious surface areas in a sort of some form of a future, which is a theoretical maximum. And then if there's time at the end, I'm going to go through some FME tips and tricks, which I've found pretty useful, and I sort of learnt them along the way through this project. So yeah, I did a bit of a dry run last night, and it took about 20 minutes to get through half of it. So apologies in advance if I'm flying through the slides. Yeah. So impervious surface areas, or ISA, a lot of you will know what it is. Old mate Lance Fraser defines it as sort of impervious surfaces can be concrete or asphalt, they can be roofs or parking lots, but they all have at least one thing in common. Water runs off them, not through them. And with that runoff comes a host of problems. So why do we care, and what are those problems? So the first big one is that an increase in ISA often leads to an increase in contaminated runoffs. And that obviously all your water runoff ends up in water bodies and streams and coastal receiving environments, and that has major consequences for sort of water quality, which is a big problem facing lots of places, but particularly Auckland. Can lead to more floods, so you've got a decrease in the time of concentration and an increase in your peak discharge. A lot of us in New Zealand last week had some flooding events after some intense rainfall. And yeah, it's easy to see. Here's an example on the right here. This is actually the Morphum car park in the basement, and you can see this is, after half an hour of pretty intense rainfall, you get some pretty quick flooding. So it also can lead to reduced stream health, both sort of stream health and aquatic life. Prevents groundwater recharge, which can intensify droughts. And this ISA is an obvious, a key sort of input into sort of urban heat island effect and increasing temperatures. So this is where normally I park my bike every morning. Luckily I didn't bike to work on this day because it would have been about a metre underwater. Yeah. So how do planning zones fit into it? Why do we have planning zones at all? The Auckland Unitary Plan sort of define their role as the management of how different areas are used, developed or protected. Zoning rules require us to consider the potential effects development or activity might have on the environment, culture, conservation, and people. So basically defining defining limits and settings for the activities taking place at that location. But of more use to us, or specific to this talk at least, is what's their role in relation to ISA. So zones seek to control the spatial distribution of impervious surface areas by limiting it to some zones, and sort of permitting it in other zones. So this kind of comes from an acceptance that certain land use practices require higher ratios of ISA, but also that concentrating your areas of high ISA in sort of single zone means it can be addressed, or the negative impacts of ISA at least can be addressed by sort of targeted stormwater management practices. So you can think about like an industrial zone, for example, will have a requirement for big building footprint. If it's a factory, you might need a big truck turning circle, which is a sort of concrete or hard seal turning circles, and so the planning zones are meant to have those sort of requirements built into them. So I'm going to introduce you to a long-running project that Morphum's been working on, and something called the maximum development scenario. So the Auckland freshwater management tool is it's a huge multi-year project that we've been working on with a company from the States called Paradigm and Auckland Council. And if I can simplify it or break it down into its sort of essence, there's three main overarching goals. So the first is to define why and how bad water quality within the region is. So that's kind of our current state, our baseline. Then we need to identify how much worse that water quality or those water quality pressures are expected to become due to population growth and our changing climate. And then we need to identify what we can do to improve or at least maintain our current water quality. So there's heaps of options in terms of actions we can take now. And that includes things like structural devices such as constructed wetlands or rain gardens. We can introduce land management practices like riparian planting, or we can look at introducing legislation change. So limiting or restricting certain roofing materials or brake pad materials, or encouraging the use of like on-site rain barrels and retention tanks and things like that. So there's lots we can do. But what I really want to focus on in this talk is that second point, and so start to think about how we can predict future scenarios. So when we start to talk about modeling future scenarios and predicting things, we kind of enter the realm of dark arts. And so what we normally like to do is consider a range of potential scenarios. And so that's where the planning zones come back into it. So the maximum development scenario is a way to sort of set the bookend or the upper threshold of what your region might look like if every single parcel was to be developed to its sort of theoretical maximum. So in this image here on the left, you've got, let's say, a pre-development parcel. It's a single house with a nice backyard, but someone's decided to develop it and put a second property on the back, and you can see that this is all happening within the guidelines of the zone limits, but it's totally increased the ISA by a factor of more than double. So it's increased the building footprint, it's increased the paved area and things as well. But we also need to look at the existing state of land development. So we know that lots of parcels are already have more impervious surface areas than their zone sort of would like them to have or permits them to have. And that can be for a lot of reasons. It could have been developed before the unitary plan came into place, or they could have had special consent granted, or there's a whole raft of reasons. But basically what we're trying to do with this maximum development scenario is look at the theoretical maximum, and if that's above what's already in place. So it's kind of the extreme case. So this is kind of a very high level geospatial overview of what we did in FME. We've got a number of inputs up the top, so the planning zones, the LINS parcels, which is the national data set, and a land use layer. Throughout this, we tried to design the workflow to be flexible and move it around different regions, different places in New Zealand or even overseas. So wherever possible, we're trying to use dynamic inputs and things like that. So we take our 3 big inputs and we mash them up in a geospatial intersection, and that gives us this sort of the intersected parcels with all those attributes. So that's kind of your existing baseline and how your land use or your ISA is distributed through each parcel. And then the second sort of key input is this ISA assumptions table by zone. So someone gets the delightful job of perusing all of the planning documents and pulling out things like maximum building coverage and maximum paved area and things like that. So not the most doing work, but then that goes into a Excel spreadsheet, which kind of gets read into FME and becomes the sort of the lookup table. So yeah, once you've kind of got your format, you can just sort of add planning zones as you go. And so then from that point on, we're just doing a fairly basic comparison between the potential ISA scenario and the existing ISA. If existing is already above what's sort of permitted by the planning zones, then we just sort of carry on with that parcel. We never assume that a parcel is going to reduce its ISA. It can only increase in the future, which might not be the case in all cases, but it's the most likely scenario. And off to the left there, we've got a branch for sort of development rules. And so I won't go into the details here, but within the planning zones, there's a whole raft of special zones and special rules that are zone specific. So for example, the rural conservation zone, if the parcel area is greater than 2,000 meters squared, the building footprint must not exceed 265 meters squared. So there's all sorts of hard limit thresholds within your kind of more broad sort of terms as well. So we're applying those rules as we go, and then that sort of feeds into that potential ISA layer as well. So this is what it looks like in FME. It is often with these projects, they often start off nice and easy, and then as you sort of dive into them, you uncover all sorts of quirky things with the data and quirky things that you need to do. So they grow and grow and grow. I don't think we've got time to go into all of the data input challenges, but what I do want to highlight is that the great thing about FME is that it works with so many different data formats. So whether it be a sort of a flat file in a spreadsheet or a web service, hosted on the web, you can use FME to access that data and start to clean it up and do what you need to do. So that was a huge win for us, moving from some other software to using FME. But there's also lots of challenges with model inputs and sort of parameters. We had such a cross-section of people working on this project, planners and engineers and all sorts, who have no idea what FME is or what it does or how to open an FME file and look at the parameters. So we were challenged with a way of maintaining our parameters outside of FME. And hopefully I'll have time to sort of show you our approach there at the end. And then finally, processing time is obviously a big one. We're talking about some pretty huge data sets and really high resolution data sets as well. So the land use layer in particular is, it's a polygon data set with some areas less than 2 meters squared and things. So we're doing lots of spatial intersects and summarizing and statistics on really sort of fine detailed data. So here's a quick overview of an example of the output for the Tamaki region in Auckland. So it's just sort of, you can see it moving between the existing ISA and the maximum permitted sort of scenario. So there's obviously an increase right across the board, but on top of that, you can see specific areas increasing significantly, and some areas aren't actually increasing much at all because that existing ISA is kind of towards that ceiling already. But if you dive in deeper, you can start to answer questions like which properties can be further developed and by how much. So what sort of potential is there for each property, and also which properties are already exceeding that current zone limit. So hopefully, I'm just going to switch my screens across, and hopefully we can jump into a live example. And yeah, I'll just go through, what's the time? Yeah, I'll try and be quick. So this is just showing the parcels broken down into their zones. So you can see sort of large areas of rural out to the, it's actually out to the east, and yeah, kind of your residential and commercial and industrial zones kind of around by the Tamaki River. And there's lots of different ways you can symbolize or present the data. So if I turn off this is showing, the blue is showing where the MPD scenario results in a ISA increase from what it currently is, and the orange is the opposite. So where the existing ISA is already more than what's sort of theoretically limited by the zoning plan. So I was pretty surprised to see how much, how many parcels are already over and above, which I found quite interesting. So if we zoom in to look at one, let's see, this one I think. Yeah, you can see the classic kind of scenario where someone's built up their property. Some of them look like they might have multiple properties on a single parcel, and they're kind of starting to push that upper limit. And if we drill into them a bit, you can see, you can do some cool kind of quick analysis, quick comparisons on where that ISA distribution is coming from. So their roof is obviously really kind of over and above what it should be based on their zone. So not saying that these guys are breaking the law. They may have, they may have got consent to do this, and that's totally fine. But it's just a interesting way to sort of get a quick look at how many places across your region are sort of either above that sort of limit set by your planning zones. And quite another way to look at the data is through is kind of looking at it in a 3D perspective, which, to be honest, doesn't add a whole lot, except for it is quite a powerful tool for, once the data loads, that is, showing just where that where the significant areas of growth are showing. So in this example, we're looking at the potential for each parcel to increase its ISA. So the greater the, we're extruding the parcel footprint by its ISA increased potential. And so you can see that the rural areas largely aren't going to be changing at all. But theoretically, some of your residential zones along the beachfront, or some of your more commercial or industrial zones have a lot more development that can go into them. So that's quite an interesting view. So I think I'll rip through the tips and tricks. Maybe I'll just choose one or two because I don't want to eat into the next person's time. I think, yeah, the biggest one for us was the workspace parameters. And what we ended up doing was creating a spreadsheet that sits outside of FME, and that lets people from all walks of life open that spreadsheet, look at the thresholds we're using, look at the parameters, read the justification, understand it, and then flesh out the parameters description and things like that. And then we bring that into the FME environment through a couple of tools, but nothing crazy. We're just doing some regex expressions to clean up the parameters. We're exposing them, I think, as we've seen in some of the previous talks. And then once they're attributes within a table in FME, we can start to use them in subsequent transformers. And the beauty of this is that anyone can update that spreadsheet, and as long as we trust them and we think they know what they're doing, we can rerun our workbenches and pull through all their changes. So yeah, I'll leave it there, I think. I've got a few more, but I think in the interest of time, I need to let the other people start. So I'll stop there. And if you do have any questions, yeah, just give me flip me an email or get hold of me through LinkedIn or whatever. And yeah, so thanks for your time. Cheers.